Hi guys, welcome back to my channel Pirai Academy. In the series of Zoho interview question, today we are going to see about a question called Fibonacci number. It is Leetcode question number 509. So basically many people know this Fibonacci question, but they don't know where it is derived from. Okay, they just know the code, the C is equal to A plus B, A is equal to B, B is equal to C, like that. But they don't know from where, from recursion, how it is derived. Okay, basically there are number of steps to be derived for this Fibonacci optimized number, sorry, optimized code. Okay, it will be from recursion, then it will be catchy, then it will be dynamic programming, then only it will be space optimized approach. Okay, then only it will be like C is equal to A plus B, A is equal to B, then B is equal to C, like that, a short code. Okay, don't memorize this types of question. Okay, because many of them are memorized, and once it is asked in a technical, okay, technical round, they are just don't know how it is derived from. They are just writing the directly the optimized approach. Okay, so that's the reason why I want to make this Fibonacci number for a separate video. So just don't skip this video. You can see this in a 2x, but don't skip this video. Okay, let's get started. First of all, what is meant by Fibonacci number? So Fibonacci number is like this. It will be initially from 0 and 1, and all other numbers will be derived from previous numbers sum, previous two numbers sum. That's the exact thing. So see here, initially 0 and 1, and then for this third, what should be? It should be the first series number and second series number. It will be 0 plus 1, which is equal to 1. Again for this 2, how it derived? It is from 1 plus 1. Again here 1 plus 2. Here 2 plus 3. Here 2 plus 3. Sorry, 3 plus 5. It will be 8. Again 5 plus 8. It will be 13. Again 8 plus 13. It will be 21. Like that. Okay, it will be like sum of previous two numbers in that series. Okay, that will be leading to the third number. Like that. Okay, fine. If n is equal to 6, then you want to return 8. If n is equal to 8, then you want to return 21. If n is equal to 3, you want to return 4. If n is equal to 0, you want to return 0. This is what a problem statement in the Leetcode platform. Okay, how to solve this in a brute force approach, or how it is derived at a scratch. So what is this series is telling? It is like, if we want the current value, then we want to take the previous value plus previous value. So this is the main thing, right? Okay, we can also tell in terms of mathematics and also in coding, like if we want nth number, then we want to add n minus 1th number plus n minus 2nd number. Can you understand this? Okay, this is simple math and also coding format. Okay, so by using this, how we can do this? Okay, if n value is 5, okay, take for example n value is 5, then I want to just add, what are those? I want to add 4 and third value. Okay, again for this 4, again I want to add 3 and second value. Again for this third value, I want to add second value and the first value. Okay, again for this 3, I want to add second value and the first value. Again for this 2, I want to add first value and the 0th value. Here also first value, 0th value. Here we know the first value. We know first and 0th value. 0th value is 0 and first value is 1. So we know, right? So just stop here. Stop here. Don't go. Now here alone it will be first value plus 0th value. Okay. Now tell me, what is the first value? It is 1. Okay. What is the 0th value? It will be 0. Here itself you can see here these two. So these two are the basic. From this only we are just building up. Okay, now again, so here 0 plus 1 is 1. Again here also 1. So 1 plus 1 is 2. Can you understand this? Here also, here 1 and 0. So 1 plus 1, sorry, 1 plus 0 is 1. So 2 plus 1 is 3. So here comes 3. Again here also, here 1, here 0, 1 plus 0, it will be 1. Here also 1, so 1 plus 1, it will be 2. Okay, again 3 plus 2, which is equal to 5. So 5 is my required answer when n is equal to 5. Can you understand this? Okay, so this is basically a recursion tree. Okay, in recursion tree, it will be going along like, first of all, it will be seeing this 5, then it will be going this 2, 4, then this 3, then this 2, then this 1. So it is a base case, base condition. So it will be again go here, come here, then go here, like that. Can you understand this? Okay, so it is a recursion. So let me first show you the recursion code, then I can show you how to optimize one by one. Okay, so don't be hurry, just wait. So see here, first of all, I will be taking a base condition. What is my base condition? These 3 lines of code will be generating my Fibonacci series. That means nth Fibonacci number. Okay, so see here, first of all, if n is 0, then what should I return? I should return 0. If n is 1, then what should I return? I should return 1. Or else what should I return? I should return what is my previous value and previous value. Okay, so that's what n minus 1th value and n minus 2nd value. Can you understand this? So here comes the recursion call. So this is separate recursion call and this is separate recursion call. Can you understand this? Yes. So this is how a simple recursion works in the Fibonacci series. So let me comment it out. So what is the time and space complexity? So I can say my time complexity will be O of 2n, because for each and every number we are just splitting to 2. So for n numbers it will be 2 power n. Okay, and space complexity will be O of n. You may ask how it is O of n. There is no space. Yes, it is space. We are using an auxiliary space called recursion stack. These all will be operated using the recursion stack. Okay, to know about this recursion stack, I will be giving the recursion playlist in my description. Just go and watch that playlist, the basic, so that I will be telling you how that recursion stack work, that entire logic. Okay, so that's why it is what space complexity of O of n. Okay, whether we can optimize this. Okay, so let me want to tell you a logic behind it. So see here we want to find the third value, and similarly here also we want to find the third value. Okay, something hits. Here we want to find the second value. Here also we want to find the second value. Here also we want to find the second value. So it is like I already know what is the value of this 2. Okay, then why I should again want to find this value of this 2? Can you understand this? Basically, how recursion works is, I want to tell you this clearly. That's why I'm again drawing it. Okay, initially function of 5. Okay, it will be calling what? Function of 4 and then function of 3. Okay, and here again it will be calling function of 3, like that. But in real time it is not BFS. BFS means level by level. It is not level by level. In real time it will be depth. Okay, when this is calling this f of 4, f of 4 again calls f of 3 and f of 2, but f of 2 is not executed till now. It will be immediately going to the next f of 3. Then this f of 3 will be calling f of 2. Then this f of 2 calling is f of 1. Now it is base condition. So it will be returning here what? 0. Sorry, 1. Okay. And again, then only it will be going for f of 0. Can you understand this? Again, it will be returning 0 and it will be returned here. Now this will be returning 1 because 1 plus 0. Okay, so that it will be returning 1 because these 2 recursion calls are completed. Now only this will be going for f of 2. Okay, again here also f of 1 and f of 2 will be completed in the DFS traversal, not BFS traversal. Okay, again here, from here also it will be sending 1 and here it will be 2 and 2 will be sent here. Now again here comes f of 3, like that. Can you understand this? So for each and every number I already know, then why I want to go further beyond? See here, I already know what is the value of this f of 2, right? So I can just ignore this and I can tell you that it is only this value, this 1. Okay, because I already saw that and it is what? Result of 1. So I can directly tell this is 1. Okay, and I already just saw this 3. So I don't want to go beyond this. I directly tell that it is 2. But how we can do this? We can do this using dictionary or hash map. So it is basically like you are just moving in two paths or two streets. Okay, two streets. Okay, while you are moving to one street, you will taking each and every detail of the street into a separate memory, like in your brain or in taking notes like that. Okay, and when you want to again go to that street, okay, you don't necessarily go into the street along the way. You can take that note and see the detail there. Okay, so this step is called memoization. Just storing in a memory to optimize my time complexity. Can you understand this? Yes. So it is basically like we will be storing each and every detail so that we don't want to go beyond this. So I don't want to go here, I don't want to go here. So that now my time complexity will be reducing to what? My time complexity will be reducing to O of, basically I am using what? A dictionary or a hash map. For this hash map, it will be, I am just going along n numbers, and to just insert into the hash map and retrieve from the hash map, it will be log n. Okay, and what is my space complexity? It will be, I am taking hash map as well as a recursion stack. So it will be O of n. So this is my time and space complexity analysis for hash map approach. Okay, now whether we can still optimize this time complexity. Yes, we can optimize it. So here comes matrix, because in my hash map I want to check whether that element is present or not. Okay, and I want to check whether I can I want to take an element. Okay, I want to take the answer, like whether it is in a memory, I want to take that, right? So for that only it is taking what? A time complexity. So if I use a matrix, then for assigning in my value in my array or taking a value at a respective index in an array is what? O of 1 operation. So I can cancel out that log n operation, right? So now I will be showing you the code of hash map as well as the matrix in the Java, okay, so that you can understand the difference between them. So see here I am just writing the recursion code, right? So this is the basic recursion code using the hash map. So initially I will be initializing a hash map like this. Okay, hash map of integer and integer, because n is also an integer and also its result is also an integer. That's why I am just assigning as a DP. It is dynamic programming. That's why I am using DP. Okay. Now in this helper function, I will be passing my n value and also the hash map that I created. Now if the n value is 0, I will be returning 0. If n value is 1, I will be returning 1. That's all same. But I will be inserting only one line. What? If my hash map contains that n, then I will be just returning that value. Can you understand this? Yes. Now similarly, I want to just take the answer of the current value into my hash map. Okay, which means if I know that Fibonacci series of 3 is 2, then I will be taking key as 3 and value as 2, and I will be storing in the hash map, so that in future if I want the third element again, I can easily extract from what? From that dictionary or hash map. Okay, that's why I am just storing in my hash map here, and I will be returning my value. Okay, and just I will be returning this helper function value. That's it. Okay, so this is what the hash map approach. Similarly, instead of just declaring the hash map, I will be commenting this out and declare a array. For example, if there are 2 parameters, then we want to use a 2D array. If I have 3 parameters, I want to use 3D array. But here it is 1 parameter, that is n. Here there is only one n, right? So I want to use 1 parameter. So I want to use a 1D array. So here comes a array. I am initializing n plus 1. Why? Because it will be starting from 0 and ending up to what? N. So n should be also in the index. So that's why I am from 0 to n plus 1. Okay. Now I will be filling this entire array with -1. Okay, I will be telling you why. And I will be returning the result of the helper function. Similarly, in this helper function, I will be commenting this hash map and just uncomment this statement. What this statement means? This statement is if the array's current n value, okay, is not equal to -1, which means it is updated something else, then I want to just return that n value at that memorization array. Okay, and I will be just commenting these out, and I will be directly here in hash map. I want to take the result and separately store it, but in array we can do this simple step, shorthand in Java. Okay, I can directly store that result into the DP array and also return the DP array similarly. Okay, so this is the similar change for using the array instead of hash map. Okay, because I want to tell you all the kinds of approaches we are going to use here. Okay, fine. Now tell me, what is the time complexity for using this? It will be O of n. And what is space complexity? It will be O of n. Okay, now whether we can just modify this or we are just making this as efficient code. Yes, we can also make this into a efficient by just optimizing the space complexity. When I can optimize this space complexity, what are the two factors that are affecting as of now? It is, one thing is recursion stack. Okay, that's why we are just taking a space. Okay, and also we are taking a array that also taking some space. So I want to just optimize these two things, or I want to just remove these two things such that I will be space optimized this solution, right? Okay, first let me just focus on this recursion stack. Okay, hats off. Now what is the code? Let me quickly write here. If n is equal to 1, then I want to return 1. Okay, then if n is equal to 2, then I want to return 2. Okay, or else I want to check whether if my dp of n is not equal to -1, then I want to return my dp of n, right? At last I want to return my function of my dp of n is equal to function of n minus 1 plus function of n minus 2. This is the entire code, right? So now while converting this into the non-recursion, we want to go with a looping. Okay, so this process is called tabulation. Okay, just converting the recursion code into the looping code. Okay, so this step is called tabulation. So in this tabulation, first I will be taking a DP array. Okay, first I will be taking a DP array. For example, if n value is, say for example, it is 6. Okay, then I will be taking 0, 1, 2, 3, 4, 5, 6 up to 6. So this is my DP array. Okay, and initialize this everything as -1, like I have done in recursion code. In recursion code also, that's why that's what the DP array looks like. Okay, here also DP array looks like this, but what we are returning in the base condition, oh sorry here base condition is here 0, here also 0, I just forgot. But you okay, fine. Now just see here, while n is equal to 1, I want to return 1. While n is equal to 0, I want to return 0, right? So I will be changing the 0th index as 0 and first index as 1. Can I understand this? So this is the base condition, right? That's why I'm just changing here, and I will be starting from here. Okay, from the second index. Okay, basically when you are traversing or when you are taking in a recursion like top to down, in looping you want to go from the up to down, sorry, down to up. Okay, like that. So it will be just ulta. Okay, now here I want to take what? dp of n is equal to function of n minus 1 plus function of n minus 2, right? So similarly here also I want to take dp of n is equal to dp of n minus 1 plus dp of n minus 2, which means what? dp of n is equal to dp of n minus 1 plus dp of n minus 2. So this is what the small change we want to do here, and we want to remove this line and remove this thing because we are already just assigned the 0th index as 0 and first index as 1. Okay, and now just add it. So what is this? Here comes 1. Again when I go here, again it comes 2. Again when I go here, here comes 3. When I go here, here comes 5. When I go here, here comes 8. And I will be returning the dp of n. So just return dp of n at last. So what is the result? It will be 8. Can you understand this? So now also what is the time complexity? It will be O of n. And what is space complexity? It will be also O of n because we are taking an auxiliary space. Okay. Whether I can do this without this array? Okay, just listen this carefully. Whether we want this entire array, whether it is necessary? No, right? Because we are just only taking n minus 1 and n minus 2, only 3 values. Then why I have to take all this array? It is unnecessary, right? So now I am going to take only 3 elements in an array. Okay, and initially these all will be minus 1. Fine. Now just take for example n is equal to 6. Okay, then what is my first step is I will be making this as 0 and making this as 1. That's default. Now I will be starting from where? I will be starting from here. Here I will be starting from 2 to 6, right? Yes. So I will be iterating over 2, 3, 4, 5, 6. Okay. Now it is what? 2. Okay. When it is 2, I want to just make what? This value as 0 plus 1, which is equal to 1. Okay, fine. Now when I am going to this 3, I want to add what? 1 plus 1, right? So it is like at first step I am just taking this 3 values. I hope it is clear. Okay, and at the next step I will be taking these 3 values, right? Can you understand this? In next step I will be taking next 3 values. So similarly here also, when I am taking the next value, which means I want to swap every values to the previous values. So which means I want to take this as 1. Okay, and here also 1. So this as 1, and again just leave it as 1 itself. Okay, now it comes 3. When it comes 3, again I want to add 1 plus 1 is what? 2. So bring this as 2. Okay, and what should I do? I should make this as 1 and make this as 2. Again it is what? 4, right? When it is 4, I want to take 1 plus 2, which is equal to 3. So make this as 3 and make this as, first of all make this as 2, then this as 3. Okay, again it is what? 5. When it is 5, I want to make 2 plus 3, which is equal to 5. Okay, and make this as 3 and make this as 5. Again go here, it is what? 6. So when it is 6, it will be 3 plus 5, which is equal to 8. So make this as 8 and make this as 5 and make this as 8. Can you understand this? Now that's it, finished. It is finished. So we don't want to go further beyond. So what is my answer? It is 8. Okay, fine. Now what is my time complexity? It will be O of n. And what is my space complexity? It will be O of 1, because we are taking a constant space array. We are just taking 3 numbers, right? Now this is how it is designed to C is equal to A plus B, B is equal to, A is equal to A is equal to B, and B is equal to C. So now this code looks like what? It is like for I is equal to 2, I is less than n, I plus plus. Okay, and from here what will I do? I will be taking the second index. So dp of 2 is equal to what is my value? It will be dp of 1 plus dp of 0, right? Initially dp will be of 3 size, okay, and dp of 0 will be 0 and dp of 1 will be 1, and 2 will be minus 1. Okay, now here comes dp of 0 is equal to dp of 1 and dp of 1 is equal to dp of 2. That's it. So this is the 4-line code we want to write to do a space optimization. Okay, further next to this, only the step called we want to take the 3 variables and just update here. Okay, here also I will be returning what? Returning just dp of min of 2 comma n. Why I am writing min of 2 comma n? Because it may be the second in this value, or they can give n value as 0 and 1. In case of n value as 0 or 1, it will be giving the result as dp of 0 or 1. That's why I am just using min of 2 comma n. Okay, so in code I will be changing this into the variable abc, that the traditional or the one which all are markupping in Fibonacci series. Okay, so let me show you. So hereafter we don't want this recursion. Okay, we just go with the tabulation method. Fine. Now let us go with the tabulation method. So this is the tabulation method 1. So here I will be taking up to n plus 1 the array size, okay, and fill everyone as minus 1 and fill 0th index as 0 and first index as 1. Now I will be iterating from 2 to n, and I will be taking dp of I as dp of I minus 1 plus dp of I minus 2, and I will be returning the dp of n. That's it. Okay, so this is how the tabulation method, but space optimization is not done. Okay, it is just next step of the recursion code to a tabulation code. Okay, now see here. So this code is space optimized. Okay, here I am taking only 3 sized integer array. Okay, and I am filling them as a minus 1 and making a dp of 0 as 0, dp of 1 as 1. Okay, and I am iterating over 2 to n, and I am taking dp of 2 as dp of 1 plus 0 and dp of 0 as dp of 1, dp of 1 as dp of 2, and I will be returning dp of min of 2 comma n. Everything is I written in the drawing explanation itself, right? Now at last see here I am taking abc. Okay, that markup approach. Okay, so here 0, here 1 and here 0. Everything is initialized perfectly. Now I want to check whether the given n value is 0, then I want to return 0. Given n value is 2, then I want to return, given n value is 1, then I want to return 1. After this only we want to continue from 2 to n. Okay, and just take c is equal to a plus b. Okay, and a is equal to b and b is equal to c. That's what I have done here. Here I am taking dp of 0 comma 1 comma 2, like that, three integer array size. Okay, similarly here also dp of 0 represent a, dp of 1 represent b, dp of 2 represent c, like that. Okay, so from this only this approaches came from. Okay, many of them know this approach, but they don't know the above approaches. They directly write this approach. They don't even just change this variable name. Okay, fine. And then at last I will be returning C. So let me submit this. Yes, it is submitted successfully. To know about these kinds of algorithms, just go and check out my YouTube channel. And if you really like this video and subscribe to my channel. And don't skip any videos in this playlist, because every videos are important to clear this round. Thank you.